4.4 Types of IPv4 ACLs. There are two main types of IPv4 ACLs, the standard ACL and the extended ACL. Let's talk about the standard ACL first. It checks only the source IPv4 address and it can permit or deny based on who is sending the packet. It cannot examine the destination address, protocol, or port number. Example is access list 10 permit and then followed by 192.168.10.0, 0.0.0.255. This command means that it permits packets from any source in the 192.168.10.0/24 network. Now let's talk about extended ACL. It provides much more control, and it can examine source IP address, destination IP address, protocol like TCP, UDP, ICMP, and etc. Source port, also destination port. For example, an extended ACL could specify permit HTTP traffic from network A to a particular web server. ACL 10 permits hosts on the source network 192.168.10.0/24. Because of the implied deny any at the end, all traffic except for traffic coming from 192.168.10.0/24 network is blocked with this ACL. In this example, an extended ACL 100 permits traffic originating from any host on the 192.168.10.0/24 network to any IPv4 network if the destination host port is 80. So we use the access list 100 permit TCP 192.168.10.0, 0.0.0.255 any EQ www. Notice how the standard ACL 10 is only capable of filtering by source address, while the extended ACL 100 is filtering on the source and the destination layer 3 and the layer 4 protocol information. ACLs number 1 to 99, 1300 to 1999 are standard ACLs, while ACLs number 100 to 199 or 2000 to 2699 are extended ACLs, as shown in the output below. In the global configuration mode of a router, enter access list ? You will see all these ranges. Named ACLs is the preferred method to use when configuring ACLs. Specifically, standard and extended ACLs can be named to provide information about the purpose of the ACL. For example, naming an extended ACL FTP filter is far better than having a numbered ACL 100. The IP access list global configuration command is used to create a named ACL, as shown in the following example. So first, in the R1's global configuration mode, you enter IP access list extended FTP-filter. And now we are in the extended ACL configuration mode. You enter permit TCP, and it is 192.168.10.0, 0.0.0.255, any EQ FTP. And then the next command is permit TCP 192.168.10.0 and 0.0.0.255 any EQ FTP data. Let's summarize the rules to follow for named ACLs. We assign name to identify the purpose of the ACL. Names can contain alphanumeric characters. Names cannot contain spaces or punctuation. It is suggested that the name be written in capital letters. Entries can be added or deleted within the ACL. This figure shows the recommended placement of standard and extended ACLs. The objective is to prevent traffic from 192.168.10.0/24 from reaching 192.168.30.0/24. So for PC1, the 192.168.10.0/24 is the source network. PC3, 192.168.30.0/24 is the destination network. The traffic travels from R1 to R2 and goes to R3. So we put the extended ACL. We place it near R1, close to the source, because an extended ACL can specify both source and the destination. R1 can immediately block any traffic going from 192.168.10.0/24 to 192.168.30.0/24. And then, yes, we do need a standard ACL. We place that near R3, close to the destination. A standard ACL checks only the source address, so placing it near the destination prevents it from unnecessarily blocking 192.168.10.0/24 from reaching other networks. Here, let's talk about the factors for influencing ACL placement. There are three main factors. For the extended of organization control, so placement of the ACL can depend on whether or not the organization has control of both source and destination networks. Also, the bandwidth of the networks involved. It may be desirable to filter unwanted traffic at the source to prevent transmission of bandwidth-consuming traffic. Also, the ease of configuration. It may be easier to implement an ACL at the destination, but traffic will use bandwidth unnecessarily. An extended ACL could be used on each router where the traffic originated. This would save bandwidth by filtering the traffic at the source, but it also requires creating extended ACL on multiple routers. 4.4.4 Standard ACL Placement Example. The figure shows why a standard ACL should be placed close to the destination. Over here, the source is 192.168.10.0/24 at site A. The destination to block is 192.168.30.0/24 at site B. The traffic path is from R1 to R2 and then goes to R3. The standard ACL should be placed on R3 near the 192.168.30.0/24 network, because a standard ACL examines only the source IP address. Placing it near R1 could block 192.168.10.0/24 from reaching other networks as well. By placing it near the destination on R3, we can block from 192.168.10.0/24 to 192.168.30.0/24, while still allowing 192.168.10.0/24 to 192.168.31.0/24. R3 has two possible locations for standard ACL. The first one, R3, the S0/1/1, that's the inbound. Traffic from 192.168.10.0/24 enters R3 through this interface. If we block the .10 network here, so the .10 to .30 will be blocked. .10 to .31 is also blocked. This is too restrictive because the ACL cannot distinguish between the .30 and .31 destinations. The second one, R3, that G0/0/0 is outbound and is the best choice. Apply the ACL as traffic leaves R3 towards the 192.168.30.0/24 network. Now, only .10 to .30 blocked, and the .10 to .31 is allowed. 4.4.5 Extended ACL Placement Example. Extended ACL should be located as close to the source as possible. This prevents unwanted traffic from being sent across multiple networks, only to be denied when they reach to the destination. However, the organization only can place ACLs on devices they can control. Therefore, the extended ACL placement must be determined in the context of where organizational control extends. In this figure, Company A wants to block FTP and telnet traffic. The source is 192.168.11.0/24. The destination is 192.168.30.0/24. And we're gonna permit all other traffic. The extended ACL should be placed close to the source on R1. There are two possible locations. The R1 at S0/1/0, the outbound. The ACL would examine all traffic leaving R1, including traffic from both 192.168.10.0/24 and 192.168.11.0/24. It can work, but the router has to examine more traffic than necessary. We can also try R1 at G0/0/1, the inbound, and this is the best choice. This interface receives traffic directly from the 192.168.11.0/24 network. Therefore, the ACL examines only traffic from the source network that needs filtering. The result is, for the 192.168.11.0/24 to a FTP or telnet, and then to the 192.168.30.0/24 is denied. And the 192.168.11.0/24 to other traffic, and then to 192.168.30.0/24 is get permitted. A question can be, where should we place the extended ACL? The best solution is to place the extended ACL on R1, because Company A controls R1, and the extended ACL should be placed close to the source. There are two possible interfaces. R1's S010 outbound. It works, but examines all traffic leaving R1. That includes traffic from both 192.168.10.0/24 and 192.168.11/24. More packets are processed than necessary. And we have R1 G0/0/1 inbound. This is the best solution. This interface receives traffic directly from 192.168.11.0/24. Only traffic from the network that needs filtering is examined. Unwanted FTP and telnet traffic is blocked before it travels across the event.